Picture this. You wake up and everything that normally blinks or buzzes is silent. Your phone is a brick. The coffee machine is lifeless. GPS has vanished. The only light outside is an eerie green curtain rippling across the sky. Overnight, the sun fired a magnetic cannon at Earth and it hit. What happens next? Welcome to MindSpark. Science Now, the show that reverse engineers worst-case scenarios so we can build better futures. In next few minutes, we'll crack open the science of solar storms, revisit some hair-raising near misses, and map the dominoes that would topple if a truly big one struck today. Let's spark some minds. The sun breathes on an 11-year rhythm, riding the crest of solar cycle 25. With peak sunspot activity forecast for July 2025, during these peaks the sun sometimes unleashes coronal mass ejections, CMEs, billions of tons of magnetized plasma hurled into space. If a CME's magnetic field tilts southward, it locks onto Earth's field and pours energy into our magnetosphere. The resulting geomagnetic storm is graded from G1 minor to G5 extreme. Severe storms force electric currents through sky and soil alike, a phenomenon scientists simply call space weather. History has already sent its warning shots. In 1859, the Carrington event made telegraph wires spit sparks and shocked the operators holding them. In March 1989, a storm plunged Hydro-Québec grid into a 9-hour blackout that affected 6 million people. On the 23rd of July 2012, a Carrington-class CME missed Earth by just 9 days. NASA estimates the damage would have topped $2 trillion. And in May 2024, the strongest storm in 2 decades painted the skies with auroras, shoved GPS signals 70 meters off target, and cost U.S. farmers $500 million during planting season. History keeps murmuring, next time, I won't miss. If that next shot lands, the first domino falls within minutes. The sun's X-ray and ultraviolet flash roiled the ionosphere, knocking out high-frequency radio on the sunlit side of the planet. Transoceanic pilots scramble back to static-laced backup channels. About an hour in, satellites are pelted by charged particles that erode solar panels and can cook their circuitry. The upper atmosphere swells, dragging low Earth orbit craft off course and confusing debris trackers. GPS staggers, autonomous tractors that wandered tens of meters off their rows in 2024, become a global metaphor for lost direction. Between the 2nd and 12th hour, the terrestrial grid begins to groan. Long transmission lines act like kilometer-long antennas, channeling geomagnetically induced currents into high-voltage transformers. Once the steel cores saturate, heat builds, insulation fails, and units can explode. A single replacement takes 18 months to manufacture, and the world keeps fewer than 3% of the spares we'd need. Lloyd's of London calculates that a top-tier storm could erase $2.4 trillion from the global economy over 5 years. During the next 1 to 3 days, the indirect damage piles up. Municipal pumps quit, and many cities run out of drinking water within 24 hours. Data centers shift to diesel, but most have only 2 or 3 days of fuel. Cell towers may stay lit by generators, yet lose their fiber backhaul. Financial clearinghouses freeze. ATMs go dark. Food and fuel supply chains built on real-time data stall, and store shelves empty fast. Think of it as a cyber pandemic whose pathogen is 93 million miles away and impossible to quarantine. So, are we defenseless? Not entirely. At the Lagrange 1 point between Earth and the Sun, the DSCOVR and SOHO spacecraft stare straight down the solar barrel and give us 15 to 60 minutes of warning. Europe's Vigil mission, launching in 2031, will watch from Lagrange 5 and could stretch that window to almost 4 days. Utilities are armoring the grid with neutral blocking devices that cut geomagnetically induced currents once they exceed about 5 amps. These devices fired a dozen times during the May 2024 storm and saved equipment. Regulators now require real-time GIC monitoring and pooled stockpiles of spare transformers, though coverage remains patchy. The 2025 U.S. National Resilience Strategy ranks extreme space weather among the nation's top systemic threats. And international drills like Space Weather Exercise Aethel 2024 bring satellite operators, airlines, and grid managers to the same virtual table. Progress is real, but coordination gaps remain. Personal preparedness is straightforward. Keep a battery-powered AM/FM or shortwave radio light still works when the ionosphere goes rogue. Store 3 to 5 days of water and shelf-stable food. Install surge protectors that can clamp geomagnetically induced voltage spikes inside your home circuits. And download offline maps to every device you rely on. Even a powered phone may get hopelessly lost. Our civilization runs on copper nerves and silicon synapses wrapped around the globe. A solar storm doesn't care about borders, office hours, or battery percentages. But this isn't doom-scrolling. It's a design brief. We know the threat. We measure the sun every day. We're already launching hardware and drafting policies that buy us time to open breakers, reroute flights, and harden data halls. The question isn't whether the sun will swing again. It's whether we've learned to duck. You've been listening to MindSpark. Science Now. If today's deep dive lit up a few neurons, tap subscribe and leave us a review. It's rocket fuel for the algorithmic ether. Next time we'll ask, what happens when an undersea volcano snaps a global internet cable? Until then, keep one eye on the sky and maybe add space weather forecast to your morning scroll.